What is up, everyone? I am Charlie Shrem, and you are listening and watching Untold Stories, where twice a week we get to talk to some of crypto's tech, cryptography, mathematics, economists, politicians, OGs, brilliant people. Together, we get to talk to these people to understand the history of crypto, of cryptography, of Bitcoin, of technology, to understand where we are in this like societal change right now and where the hell we're going in the future. And my guest today is Dean Tribble. I'll just give a brief history. Dean, oh my God, it was so cool doing the research for the show. You co-designed one of the first smart contracting systems back decades ago called AMiX, the American Information Exchange, and you were principal architect at Microsoft. This was like smart contracts decades before Bitcoin even existed. You worked on the brokerage information system for Schwab's active traders and the WebMart electronic contract system for SunLabs. But what was really cool too is that you were the VP at Deluxe, and everyone knows that, for all of the checks, if you've ever written a check, it's probably been a Deluxe check. So we're going to talk about really, really cool things about it. I want to understand how like custody and checks actually, that whole system was working. But now you are one of the co-founders of Agoric, which is actually, and I can't believe in my decade of crypto, no one has really tried to do this before, but a proof of stake chain that integrates a JavaScript-native smart contract platform, and it comes with like a library of components, and we'll get into it. But like, pretty much, why has no one tried to do a front-facing like JavaScript style blockchain where the interactions, because like you're right, you can't, well, you didn't say it yet, but once you're stuck on a blockchain, the smart contracting language is different from chain to chain, from protocol to protocol. Thank you for coming, by the way.
Thank you for having me, Charlie. I'm happy to be here. So where do you want me to start? That's like 3 decades you just did.
I know. Well, let's start here. Elizabeth Warren recently said, and it was like co-found. She's like, I don't want the financial rails to be written by these shadowy supercoders. But you are a shadowy supercoder, kind of, and you were involved, wrote a lot of, and were involved in financial rails for decades and other types of rails. So who does she think writes this stuff, and why has the government had such a tumultuous history with cryptography?
Wow. Okay. So we went through many rounds of tumultuous history with cryptography, and it is not uncommon for people who want to have their own secrets to want to pry into other people's secrets, right? And so, I mean, I think the in some sense, it feels a lot like the same reason why people don't open source code more, right? Which is that they want control. They feel like if there's things they can't see or control, then that's somehow going to be a problem, as opposed to it's none of their business. And so that's sort of my casual sense of that. I mean, there's obviously lots and lots of details of dealing with some of these folks, and often there might be legitimate issues on either side that one needs to sort.
Yes. Yeah.
But the fundamental thing is on the side of what we do is enabling smart, free people to be free and do what they need to do and do what they want to do, and do so without without having to ask Mother May I.
I've worked as an executive for 2 software companies, and one was very open source and would fund open source initiatives and all of their code. But then I also worked for a company where I was the COO that was a software company, and they were very, very close source and on purpose. And I would talk to the CEO a lot, and I really understood in his specific case why it was important for the software to not go open source. So I guess there's always, like, the grass is always greener on the other side. There's always 2 sides to every coin in that sense.
Mm-hmm. Mm-hmm.
Tell me,
and I've been on both sides, and I fought against software patents, and I have several. And one of the exciting things about blockchain is that it gives a monetization model for open source that previously you really couldn't get. And so the fact that our company now, Agoric, is able to be open source, where in some sense, the more we can give away for people to use, the better off we all are. That's just one of the most exciting things about the company and the space that I'm now in, is that nice combination.
So Satoshi kind of incentivized open source. Is that one of the reasons why Bitcoin succeeded where the predecessors kind of failed?
I think that's true. I mean,
I never
there's a
thought of it that way.
non-trivial, that's what helped build that ecosystem, and it's the ecosystem that makes these projects happen. And so it's other people being able to be engaged, understand it, carry it forward, get excited about it, believe it because they can see it, analyze it, argue with each other about where it's going to go, all those kinds of things that creates a community that drives that development. And so that's a very important part of what made Bitcoin happen, I think.
Tell me
And
about
Ethereum and Agoric and
yeah.
Cosmos and Polkadot.
I have to say in my early years of Bitcoin, I had never even heard of the word smart contract. And until it started being talked about, Ethereum started to be conceptualized in 2013, 2014. But this concept of using these software contracts for negotiating problems is not new nor novel. You were involved in something called AMiX a long time ago. Can you really tell me about that? Because I'm so intrigued.
Sure. And I'll come back to this, but Bitcoin is a smart contract. So we'll talk about it. So what's a smart contract?
Good point.
My characterization, and the characterization that, me, Mark Miller, and others of us have had for a long time, is it's software that is enforcing the terms of a contract-like arrangement between third parties. Right? If there isn't multiple third parties that you're orchestrating the enforcement for, now it's just software. It's not a smart contract. And so smart contracts predate blockchain by a lot because, eBay, PayPal, Venmo, all those things are smart contracts. They're just smart contracts that are hosted by a third party, right? And so Bitcoin is a smart contract because it's software in the middle that is enforcing the terms of, a sender and a receiver transferring money, right? Or rather, really there's all the script and it's, here's the conditions, you can take my money, and the receiver proves they meet those conditions. And so they get the money, right? So that's a smart contract. So AMiX, American Information Exchange, predates the term smart contract that Nick Szabo came up with. And he was working on the ideas of this, concurrent with a lot of this work going on. But it was a information marketplace where if I had a problem to solve and I needed it solved urgently, I could post a consulting request and other people could come along and say, I will solve your problem for you. You pay me this much on agreement, this much on delivery, and this much on acceptance. And the terms of that, there was a process for us to negotiate and go back and forth that was all structured in the contract, in the AMiX system, so that we could engage in this behavior orchestrated by the software. And at the point where we both agreed, then we now have a contract in place where at that point, the software, the smart contract, would transfer the funds from me to the seller, to the consultant. And when they delivered, it would transfer other funds to the consultant. And if I disagreed, then I had 2 weeks to dispute and that would go into a different, workflow that was enforced by the software in order to come to agreement on who gets paid for what, and enable me to get my consulting stuff. And this had people like Mitch Kapoor and Esther Dyson. There was the marketplace where you could provide a business plan to get reviews by them, for example, or you could get advice on a marketing plan, or Smalltalk, the OO programming language, the first real big OO programming language, object-oriented programming language. There was a forum for that where if you had a problem, you could post it and someone would come up with, here's your program to solve this. And the nice thing is it wasn't just, here's a consulting thing, but it could be turned around where now that consulting solution stays up there in the marketplace. So if the next guy comes with the same problem, they could buy the solution off the shelf from this thing. Right?
Who
really
hosted
nice
that? So
market.
Was there software malleability? Is that the right term to use, where the software can figure it out in real time, or someone needs to be maintaining and changing and updating and hosting?
Well, this was very much a service, software as a service provided, before the internet, right? Clients would use dial-up to connect to this thing. And it was software as a service where, so it was more like, as I said, eBay for software consulting, where I would post, here's a fix to this problem, and people could buy it. Or someone would say, I have this other problem, I'll pay $300 for someone to fix it real quick, or $3,000 or $30,000 or whatever it is, depending on the size of the problem. And then you'd go into the marketplace, and as a consultant, you can go and look for jobs that were open that you might want to provide. Or if you had an idea, you could simply post it. Does anyone want me to do this? I can do it.
How would someone access this? How would you access this? This is not software that you can just download on a personal computer.
It was. Yeah, no, absolutely was. There was a client that you would download. You'd get a CD-ROM. I don't know if people remember these AOL CD-ROMs.
I remember.
Prop up your tables or whatever. But it was a CD-ROM, or maybe this predates CD-ROM. It was floppies you would install on your laptop.
Floppy disks.
Or on your computer. And then you'd have a dial-up modem. It would connect to a bank of servers. So now it's talking same as you would connect to AOL or CompuServe or any of these. Now it was talking to the AMiX services. And you could log in and see everything that was going on there.
That is the coolest thing.
Now, the important thing about smart contracts out of this, right? This was the first production smart contract where Phil Salen, the brainchild, AMiX was his brainchild, really had this model of having a service that could increase the ability of people to cooperate and do business with each other. That had third parties where there was a contract-like arrangement between them that was orchestrated by the software. And that sort of thing. Now, in the same, like Bitcoin is a particular smart contract, AMiX was a particular smart contract. And what Nick Szabo came in the extended community there, and this was an extended community around AMiX and Xanadu and Foresight Institute and people talking about a lot of these ideas and cypherpunks and so forth, where he could point at that and go, this idea of smart contracts, that is one. It has these characteristics. This is why it's important. This is why it's good. This is why we should do more of it. And how to recognize what's happening. And since then, of course, there have been lots more smart contracts, so we can recognize what's special about them because it's software that's orchestrating relationships, typically between strangers, right? And this is the long-term vision of, the more you can enable cooperation in the world, the more cooperative a world you get. And so by being able to make it easy for strangers to cooperate, you can encourage more cooperation.
It's going towards a more efficient market, connecting all the world and all of our brains together and putting that all together. That's the thread of the show. That's what we've been talking about on every past 200 episodes, is that exact same thing. Using the technology to bring about, like what Jack Dorsey says, not even me, is world peace. I mean, I was saying it for longer than him, but he can have the credit because it doesn't sound crazy when he says it, I guess.
People did think of that before Jack Dorsey, no question.
Good. So why Solidity? Like when Ethereum so you had Bitcoin that was written in C, right? C++. C++. I know you could tell that all I could do is Python. That was but I remember a lot of people jokingly say, at least it's not PHP. Now I'm going to get a lot of developers send me emails like, what's wrong with PHP? It's like, no, like, don't write anything ever, but JavaScript. But why Solidity? Talk to me about Solidity. And Vitalik's idea was that every smart contract that will ever be written will be written in Solidity across Ethereum, which was the only thing at the time. I guess he didn't think that there'd be other blockchains that you'd want to have a more high level programming language that can be accessed across everything.
Well, okay, he's a really smart guy. Vitalik's a really smart guy. I'm not going to try and think about what he did or didn't think about. Any software developer that is not written a programming language, it's really irresistible to try and write your own programming language because you're sure you can do it better, right? So why Solidity? The biggest thing is, of course, they cared about being able to have, separate smart contracts work independently of each other and not be able to reach in and steal secrets or change the behavior of other smart contracts. Writing a new programming language from scratch, been there, done that. That's not actually a great idea typically because the number of smart contracts that can get real traction is pretty low and the chances of get something wrong are pretty high. Yeah. So why Solidity? The answer is at this point is, just inertia and that's the stuff that's there. As a programming language, it has some major security flaws that are really insurmountable. It's got reentrancy. That's something where, should not have done. It uses message.sender for security model. That's to us, the fundamental security flaw that again is you can't change, you can't fix it at this point. That ship has sailed. And that's one of those things where it is possible, even plausible, that elements that make it so it can't scale to millions of developers actually made it easier for thousands of developers to get started, right? The simple examples are simple. The complicated examples are basically not humanly possible. So we'll stick with simple examples, but now it's easy for us to do simple examples together and combine a bunch of these things together and get started, but we can see that security experts have routinely get security flaws in there, and there's lots of active cycles to try and protect them. But fundamentally, you keep getting these security issues and security hazards, not because these aren't really smart people, but simply because the hazards intrinsic to the execution model are just too hard for people to understand and too hard to make rapid composition with independent components come together and not create security hazards. And so, so why Solidity back then? Well, it helped people get started. Why Solidity now? I think people need to move off it.
Well,
now, it's going to be here forever, just like C++. But it's definitely not a thing that a million programmers are going to be able to succeed at, as far as I can tell.
Yeah, it'll stay a relatively niche. So why JavaScript then?
So there's a couple of reasons.
For Agoric.
A couple of reasons coming from very different directions. I've created a secure programming language and participated in others. And all 5 people that know it really think it's wonderful, right? And nobody else cares, right? So why JavaScript? Because there are 10+ million programmers that know JavaScript, right? So you got to meet people where they're at. Okay.
Yeah.
That would not be good enough, however, if it didn't turn out that JavaScript could be made secure, that JavaScript could be hardened so that so that you could build components, you could build smart contracts with high integrity. So there's an accident of history, and this is really funny that in secure operating systems or operating systems where you care about security, you have this user mode, system mode separation, it's called, where in user mode is where user programs run, the things that malicious attackers submitted. Normally even in operating systems, you're trying not to get stuff from malicious attackers, but it runs up here. And then there's the user mode, system mode separation and the operating system down below. Now, ideally, your operating system is, microkernel in small pieces, so it's very small and you can verify its security properties, but fundamentally, they have this line across them. In JavaScript, in the evolution of JavaScript, the language was evolved and standardized in the ECMA Standards Committee. And it evolved out of, Netscape and Brendan created it. And then other people tried to co-opt it and use it for their thing. And so it evolved to let's standardize the language so we're all on the same page. And the embedding in the browser was standardized in W3C. And if you've ever worked with committees, and in particular committees that have territory or any kind of politics, man, you do not step on each other's toes. So the line between the language specification and the browser embedding was a really strong, bright line that lots of people kept straight. And that corresponds to that operating system, user mode, system separation, right? User mode, system mode separation. And so the language JavaScript is actually a very pure language where you can embed it in new context, give it a new host environment that provides it very specific authority to do things as objects in JavaScript. And so now if you can lock down the language JavaScript, all of those objects, you can carefully orchestrate which parts of your software have access to them. And so the objects in Node are access to the file system in the process. The objects in the browser are access to the DOM and HTML and that sort of thing. And the nice thing is so because of that architecture, Mark Miller, our chief scientist, was able to get through the standards body into JavaScript in the JavaScript Standards Committee, the key elements to be able to lock down and harden JavaScript. So we really can take malicious code and run it in a box, even in an environment where there are secrets or other things that we would not want it to corrupt.
And that's been the biggest problem really with is how to, that's.
Yeah. And so the reason why you asked about are there other JavaScript blockchains and why isn't this used everywhere? Well, there have been efforts to do JavaScript on a blockchain, but without having the techniques and the expertise to be able to lock it down, JavaScript is too malleable. I mean, there's a Hyperledger version that does this. There's Lisk.
I understand.
Breach, I don't know. There's a few others, but you need the hardened JavaScript, which is still JavaScript. It's just that a few things that allow you to step outside your box are shut down, and you can't do that. And that lets us run JavaScript safely, run malicious code inside of a box it can't get out of, and that lets us run it in a deterministic fashion. So the same computation running on 100 different machines produces the same answer, which is something that is critical for doing a blockchain. Is you've got 100 validators, they're all running the same computation, and then they vote to agree on the answer. They better come up with the same answer, or that vote's going to fail. And we
in
saw
real
that.
time too, fast
Yeah.
too, without any latency too. You guys checking out the Summer Olympics in Tokyo? It's on right now, and the awesome folks at Bit Casino and Coin Gaming are giving away amazing Bitcoin bonuses and cash prizes. These guys have been our sponsor for over a year, always giving away so many free things to all of my listeners. So go check them out, the Bit Casino All-Star Team. From now until August 8th, you can unlock rotating prizes, free spins, cash incentives, Bitcoin bonuses when you complete their daily missions. So all you got to do is head to my Olympics promo page. If you go to untoldstories.link/BitCasino, just go there all the time. Untoldstories.link/BitCasino. We're always giving things away there. We just gave away 3 Teslas a few months ago. Now during the Olympics, there's going to be a Bit Casino All-Star Team giving away a lot of cool stuff happening. It's a lot of fun. I love doing it. Thank you guys so much for making Untold Stories possible. I love you. This is a friendly public service announcement reminding you guys that if you're using Uniswap or 1inch or any of these other decentralized exchanges, you shouldn't be. You should be using our awesome sponsor, PowerSwap, because PowerSwap is a decentralized aggregator that sits on top of all of these different other decentralized exchanges to give you the maximum liquidity. But not only do they work on Ethereum, but now they work on Polygon and Binance Smart Chain. So you can do all of these type of crazy swaps, defining, going from one token to another, to USDC, to USDT, to wrapped Bitcoin, to all these different coins and tokens, all do it in a decentralized way. Furthermore, they're now integrated in the Ledger Live platform. I love these guys. I've been using PowerSwap for over a year now because you save all of those transaction fees every time you have to hit one of these blockchains for like approving your MetaMask or sending a transaction. PowerSwap brings it all together. You predefine everything and then you hit submit on the smart contract platform and it does it all in one shot for you. So you can check them out at untoldstories.link/PowerSwap. Thank you guys for making my show an amazing one. That's untoldstories.link/PowerSwap. So if I understand you correctly, essentially our brains are these like hyper complex, let's just call them computers for lack of a better term for right now, hyper complex. And here we have these smart, I stand up when I try to explain something to myself or to the listeners when I sit down. I have this ball here. So you have our brains where these hyper complex, beings. And the ultimate goal in life is to have all of our brains to be interconnected and be able to communicate with each other with zero latency, zero packet loss, hyper efficient. The world will be a much better place. We can do all of these amazing things. And then we have this Bitcoin
I'm not sure
thing
I
and
agree
this,
with that.
but wait, we have this Bitcoin and blockchain thing. But our biggest impediment, from what I understand, is the fact that we're using these programming languages that, for lack of a better term, are like cavemen, where we can't attribute our brain. It's like when you try to communicate to your partner something and you just get frustrated that the words aren't coming out of the brain. That's like writing smart contracts. But JavaScript is like if you were a super communicator and were able to, is that a very dumbed down way
of go the other direction on that a little bit, which is latency is intrinsic in the universe. And so lots and lots of systems have tried to pretend that everything could be zero latency. That, Peter Deutsch has this beautiful myths of distributed systems. Everything's zero latency, everything's perfectly efficient, everything's encapsulated. There's a bunch of myths that people want to achieve. And I think that's the wrong direction to go. The right thing is to really accept the, key elements of the world where there is information over here and information over there, and there is a true latency between them, and that is an arbitrage opportunity. That's an information differential between these two, and that's and light speed requires that. I mean, that's fundamental physics requires.
You need the other side. You need the pull.
As the real model.
Yeah.
Now I want
I see what you're
this guy
saying.
to be able to communicate with that guy, where it's not that they pretend that it all happens atomically. Because one of the problems with Ethereum is you pretend that it all happens atomically, and so you end up with, okay, let's stop the world, allow some jerk to take a flash loan where obviously other people would take him to the cleaners if you were in a real economy, but they're going to take a flash loan, pretend they have $1 trillion, go buy all the governance tokens and bribe all the officials, right? And the world just doesn't work that way. And it's really frustrating to me to have a model that doesn't well adapt to what actually works in physics and in the world. And instead having these, no, I am a sovereign individual. I have I then get to communicate with people, more or less successfully to cooperate. And I want support to cooperate, but I don't want people reaching inside and looking at my thoughts. I want to be able to decide what I share in a particular context and do so. And so I want to do that efficiently. And I want to be able to agree to be constrained or behave in a particular way efficiently. And that's where the smart contracts come in. And I want a network of these, sovereign environments all cooperating. And I want it to be, valuable for them to cooperate rather than attack each other. But that's one of those things where if you're going to have freedom, you have to have in some sense, some ability to do both.
Yeah.
But I want to be invulnerable to those attacks, right?
You need if latency didn't exist, then there would be no need to fight against it. You need the natural pull of the universe in order to create that perfect counterbalance. So like, I almost wonder if Satoshi thought about this when he tied Bitcoin's, the block timing and its distribution and its security model to probably the only natural thing we can predict in the universe, which is like how fast it takes to prime a number.
Right. Latency is, I almost certainly knew Satoshi, right? I have no idea who it is, but I claim it's Alpha, but or he's one of the many things. But I almost certainly knew Satoshi out of all the cypherpunks. And awareness of latency, awareness of decentralized, activity, and the fact that people in different places have different information. And that's what powers markets, is the fact that people have differential information. That's something that
informational arbitrage.
You're certainly aware of, right?
There are business people who make money just on being able to understand the West, like the American stock market versus the Chinese stock market. Mm-hmm. And they have investment bankers who literally make billions of dollars a year just sitting in rooms explaining the differences to people. Informational arbitrage. That's what it is.
And information arbitrage, and information is necessarily a local thing, and it spreads with some time delay. And that's a significant part of how markets function. This is and a lot of the Hayekian model of economics is about information differences and information propagation as much as it is about about money. And so we really, we think about our designs that way. We think of how we design components and smart contracts that way. And that's sort of the reality of how the world works. And the better you can match that, the more you can support people participating in that.
You're kind of almost breaking down some of my fundamental beliefs, because I always looked at, in the past few years at least, as I want to help people get on an even playing field when it comes to what information they can access, how fast they can access it. And that will make, we'll be in a much more open data society. We'll be in a much better place to live in.
Right.
But if we need to accept that the latency does exist and we need to keep it somewhat that way, how should I be looking at innovation then? What should we be doing? Yeah.
So you can aspire to things that are not possible in order to get things more in that direction, right? It's just important to keep in mind the fact that it's not possible, partly because people who have tried to, let's make everything even, let's give everyone all the same information. I mean, that's sort of ignoring the fact that the world doesn't work that way. You can't get there, and they try to do things that turn out to be dumb, right? And if instead you can go, okay, why do some people have these advantages of information? And how can we offset that? How can I, they've got natural ability to aggregate. Do I just not share as much with them? Do I try and make incentives for people to share with more people? Do I try to have a competing thing that will then provide data out? Now, that person that's got a nexus of information coming in, they're going to have a speed advantage over someone who's giving information in and then getting it out. But they might not have an advantage over a community that is gossiping all of that information in a decentralized fashion. So by really understanding that, that communication takes time and storage costs money, and verifying your information is correct is critical. You can design a system that is better able to balance the opportunities, for people, which is kind of to me the most important thing, right? So it's not that everyone should have the same amount of money; it's that everyone should have good opportunity to make more money, enough opportunity to make money, to be able to have an acceptable, life. And past that, there's lots of dimensions in which people will become happy. That one person's happiness might not be another person's happiness, and I don't presume to dictate. Right?
Yeah, everyone's hyper unique, and every day I'm always trying to tell myself to never, as a voluntarist, never force, you can believe and you can believe whatever you want, but don't force like your will on
That's
someone
right.
else. I actually did it yesterday. I felt super bad about it. I couldn't sleep last night because of a situation. I felt that I had a really strong belief about something and I was kind of pushing it on someone. I had to take a step back, and this is kind of like my confession. But it's a really shitty feeling when you do it. Um, because the world, when the world can be and should be a better place when we're not forcing our will on people, and sometimes we forget, and we're not all perfect. So I mean, wow, we didn't even get to talk about Deluxe yet. I want to talk about that, but
Sure.
I don't, and we'll get into that in a second. But I want to understand then what with Agoric and JavaScript, what you kind of aim to do, and then at the same time, as I understand, you have a very innovative token economics, but you include also a lot of libraries of pre-written modules that allow people to kind of jump and do things almost immediately.
DeFi Legos, man.
DeFi Legos, I
Yep, yep,
love
yep.
it.
But for real,
Yeah,
not,
yeah.
yeah.
Is
So where do
this
you
the
want to start
next
there?
step? Well, is this the next kind of era? Yesterday I was doing a show where I was trying to understand the next level. Is this the next? It looks like the way you're building blockchains and protocols is the same way the early uh, pieces of the internet were built, and then how kind of you look at code nowadays where you have libraries and modules that are already pre-written and you can access, and and even to run some things you need to have certain things downloaded already and pre-set up. I'm still
So
trying to get
so
Python
I
3 working on my computer.
Yeah, so my strong analogy is React.js or Node.js. So for people not familiar, those are JavaScript libraries. React.js is a framework for doing user interface components. Node.js is a platform for doing server-side JavaScript. And Node.js has spread wildly in the software as a service industry because you could start to rather than building your entire application from scratch, you could do npm install Stripe integration, npm install database integration, npm install blah blah blah, right? And turns out on GitHub, if they look at applications, they did an analysis, and on average for applications that are on GitHub, only 3% of the code is unique to the application, and 97% of it came from packages that were installed that were built by other people. Right? This important model that you get in OO languages, from Java to JavaScript to C# and so forth, is that I can get a component that someone else built and I can use it without just copying the code, right? And the code copying in Ethereum, it's a little bit successful. That's what we were doing in the 70s and 80s, but for every success, there's a horrible failure where someone copied something that had a bug and they never got the bug fixed, and they got.
We see that all the time. When someone's token contract gets hacked into, it's like it's like, oh, this token was hacked for $20 million and these other 30 tokens were affected. Which one's copy and paste.
And they're using the same code as 30 other people because they copied it, and you can't fix it in one place. You now got to fix it.
That's not a bad thing. You're saying that's kind of how things should be done, right?
No, copying code is not the way things should be done, right? So Uniswap copied the compound governance token. They made just a few modifications to integrate it in, and that was a big success, right? But dForce did exactly the same thing, and they lost $25 million because the gap between these two, they didn't wire up because they didn't have the secret back channels to the people who wrote the code, right? Whereas when you build components and you package them up for reuse, it's much more likely you'll be able to take some code unchanged. And so it's not that you're now maintaining the code, it's that you've got this component that has been battle tested, that has been reviewed, and you're just adding parameters. So, and so, for example, I mentioned React, right? React is a user interface framework where I can take a slideshow component and I can take a Stripe integration, put them together with a little bit and a nav component and a few other things, and launch my art website to sell my art, even though I might not have been skilled enough to make a slideshow component or know enough to do Stripe, right? And that ability to build on the shoulders of other developers, where I'm not copying the code and understanding it and changing the code of the slideshow, I'm able to take that component specialized for my use because I can see lots of reviews about it. I can see several people have successfully used it. And now I just need to parameterize it for my set of images and for my currency, and I'm done, right? And it's not that I changed the code, I just added these arguments and launched it. That's a huge ability to, that's a huge point of leverage for developers where they get to now use, 97% of the code they build is these components they got from other people. And as a result, now developers in JavaScript, developers of React UIs or Vue UIs or whatever it is, they can do things, build applications that are more responsive, more internationalized, mobile friendly, faster, flashier, and more, and more interactive than an expert could have done 15 years ago.
Oh, wow.
Simply because that beginner gets to build on all of these components. And React is this framework that lets you put them together well to produce an interesting application and compose them successfully. So we're doing the same kind of model for smart contracts. We have a framework where it's not about rendering graphics, it's about trading and exchanging in digital assets. So I can grab an auction and a governance component and an NFT, a new NFT token generator, and put them together to produce my new sales application for whatever my application is, without having to be an expert that could have made that minting an NFT, or could have done the right auction, or could have made a liquidation contract that knows how to rate limit based on market prices or whatever it is, right? And so being able to have components that I can glue together, that's the thing that Agoric does. And that's what we think of as the next generation of real DeFi, because it just can make innovation so much faster. You can, build fast, you can earn fast, you can, get out into market and have real businesses quickly.
And you can probably also do things like allow for certain security for certain things, and some things do need that instant, like block time, and some things could wait a little bit longer.
Absolutely.
So it allows for a software to be done different ways, because robust software shouldn't have one aspect of it be hard coded in or specifically set. And so it's just part of the natural evolution of things that how secure or how fast something settles on chain should be a sliding. It should be a sliding mover or whatever. I feel like I'm saying this completely wrong, but yeah, you know what I mean?
That's one of those things where, proof of work is maybe important for Bitcoin, especially, but for smart contracts, it's not actually a good thing.
Right? That's what I'm getting at here. Exactly. And that's okay for a lot of people to realize. Hey, so I want to switch subjects here for a second, because I'm genuinely curious. A lot of people, so you were a VP at Deluxe checks, and a lot of people, that kind of weaves into what we were talking about. A lot of people use checks as something to make fun of nowadays, like an old archaic thing. And I want to talk about that. What I want to understand is, at the time, what is it or was it about the check that was so novel and so important and so big that it's literally taught before how to swim, how to write a check, how to place a telephone call? No, learn how to write a check first. Right. When did that happen and why?
So this is really a big deal, because what people don't understand, they make fun of checks and they don't realize how much of the economy is on that. So last time I looked at numbers was maybe 2018 or 2017, but U.S. banks process 20 billion pieces of paper, 20 billion paper checks for $30 trillion, right? So checks, people think checks are gone away. Just no, they just don't know. So if you do bill pay, 70% of your bill pay payments turn into a paper check that gets mailed to the recipient, right? But the reason is, if you actually look at payment flows, and there was a long time ago at a previous company working with some of the people here at Agoric, where we did the first electronic check effort in conjunction with Sun and IBM, and then 13 of the largest banks. And so we had a wall that had all the different payment flows of checks and ACH and wire and Swift and credit cards and all these kinds of things. And it turns out checks are a really powerful mechanism that if you could make them digital, they'd be wonderful, right? So turns out most of these payment mechanisms, a lot of people don't realize that they used to be paper, right? Credit card, you'd get a credit card slip and you'd sign it, right? Wire, there'd be a wire transfer form and you'd fill it in. And checks were the last one that there is still a piece of paper. But the cool thing about checks, right, in the ACH case, or the bank-to-bank transfer or wire transfers, it's like, I need to pay, I'm a business, I need to pay you for a shipment. So I'm going to say, hey, Charlie, I just told my bank to dump some money into your account and it's paying for this shipment, but I'm taking 10% off because, some elements were damaged, or I'm giving you a 20% bonus because you delivered and you were awesome, right? And so what that means is you're expecting $100, you got a payment that isn't $100, and you're trying to figure out, well, what did I just get paid for? I can't take the money unless I know I get paid for as a business. And so it's one of those things where it's very complicated. It is much simpler if I go, Charlie, thanks for the delivery. Here's your payment, right? And on the payment, it says, and here's
Sure.
the, $120 with a 20% tip for paying for the shipment. This is awesome, right? And so as a flow, and then you take that to your bank and the payment clears on the other end. As a flow, that works really well, right? And it works really well. I mean, the other way in which that works really well is back to that bank scenario. If I'm paying you for medical x-rays, I might want to pay you as part of a transaction where you're sending me, a gigabyte of data, right? I can't do that through the bank. They're not set up for that, right? I might be paying you for, where I'm paying you less than you said. And along with the payment, I'm going to ship you a picture of the damaged goods. And you go, oh, okay, that's fair. I'll take it. Right. And otherwise I'll argue about it. You argue about it. And so our ability to exchange metadata about the payment when I'm handing you the check is unparalleled. And that's the reason why checks are hanging on on the business side, in the shipping side, in the B2B world, is because when I pay you, I want to say exactly what I'm paying you for. And depending on our business relationship or what it is we do, I might have a lot of other data as part of that transaction, or your receipt back to me might have a lot of other data as part of that transaction. And that's a pairwise kind of thing. It's not something that a bank can universally go, here's the only metadata you're allowed to do for payment. Now, in crypto, we get some of that same ability where my ability to pay you might have lots of ability to add additional metadata or, cryptographic signature of this, terabyte of data over here in some database that I'm transferring, or those kinds of things. So, checks are not the only mechanism that gets this, but that's the reason why checks are really powerful. And so the problem was that there was a bunch of law that said they must be paper, in various places. And so the innovation of that echeck company that we did started as VerifyValid and then was acquired by Deluxe, was as much technology as navigating check law so that this electronic payment fell under check law rather than under credit card law, or what's called Reg E, which has very different, business implications.
When the first Bitcoin exchanges first came out, they had to, BitInstant included, my exchange, we had to use whatever payment rail connections from the traditional finance industry we had available to us to get people, help people get into Bitcoin. And I remember we were looking at so many things, but echeck was like, what was this? There was this like payment rail that no one really knew about or was using. Yep. And it allowed people to go from their bank accounts into Bitcoin using this, like writing a check, taking a picture of it, going into like our system. It was like a whole thing. So some of the early Bitcoin exchanges, like deposit money by taking a picture of a check into their account. Like, yeah, it's just, oh my God.
Crazy but for example, stuff. Any electronic payment, if it's a consumer payment, you've got 90 days to object to it getting processed.
Yeah.
90 days is a really long time for someone who, for a business that's doing, shipping trucks around and they've got to pay the maintenance fees. And so check payments are 4 days to take it back, or 4 days to straighten it out. Or
I didn't know that.
Depending on whether it's business to business or business to consumer.
Is that why they take so long to clear? Is that why they take so long to clear? Because there's like a delay on purpose to allow you to like debate it?
For paper checks or for non-checks?
Like paper checks. Even the fastest bank I know, the bank will clear it instantly, but they're taking the risk if they know you. But why does the bank even have to take a risk in the first place? Why isn't it where as soon as you deposit, there's some software that checks if the person has their money in that account, then it puts a temporary hold on it. It should be like an instant thing, no?
Well, so there's a bunch of regs around that and practices around that. But in fact, a lot of that does happen where if you're going, we've seen checks clear in, $100,000 checks clear in literally minutes. And indeed, electronic checks were proposed as one of the Fed faster payment rails to be able to do, payments in seconds of large amounts of money, because indeed these banks are
love writing checks.
But an important thing about checks is they work because of this mechanic and trade-off of I can give you this much, but I can lock funds and blah, blah, blah. They work even for businesses and banks that are offline. And, and so if you're online, it can all clear faster and be lower risk. If you're offline, at least money can flow. And so
Checks
So
also were
these are all-
probably one of the first, if you look at it, actually, if you look at the financial system pre-checks, it was probably the financial system probably was a place where only certain types of people can access or get in. It wasn't a very fair and equal place.
Well, and you
But
had
checks,
to cart your money around, right?
cart your money around.
Pre-check-
Checks don't
Yeah.
discriminate. It doesn't matter who's holding the check. You can be a white male. You can be it doesn't matter the color of your skin, your sexual orientation. It doesn't matter anything you do or what or how or any. It doesn't matter. And so for the first time, money didn't discriminate,
Mhm,
and that was a
mhm.
beautiful thing.
Yep.
Dean
Absolutely.
Tribble, thank you so much for coming on Untold Stories today. Brilliant, brilliant, brilliant show. You're so brilliant. This was amazing. I love this. Thank you for giving me purpose. I love it. Shows like this that give me a reason to continue doing these shows. And I know the listeners are going to love it too. Thank you so much. I appreciate you.
Well, thank you so much for having me, and I look forward to talking again in the future.
I can't wait.